Hi, welcome to Asynchronous Monday. My name is Mr. Barnes. I'll be your host for today. We're going to be looking at the law of sines and the law of cosines for the next 2 weeks. We'll be taking a quiz next Friday, not this week, but next week, about the law of sines and the law of cosines with a couple other things thrown in there. And in a nutshell, the law of sines and the law of cosines are there to help you solve a triangle. In order to solve a triangle, you need to know all three angles, all three sides. And that's what you're going to do. It's pretty much the same idea for both. They're just two different tools to help you solve the triangle, to find all the unknown parts. Now, the law of sines. Turn in your notebooks to page 74 in the upper left-hand corner. Visualize the most beautiful number 8. Actually, my personal favorite number in the upper left-hand corner, because we're going to start chapter 8. Only 2 sections of it, though. This is the 8 that I came up with. I like that one. And this, I didn't do a chapter head because it's really only 2 things. You could call this chapter the law of sines and the law of cosines. And we're just going to spend some time doing the law of sines, and the law of cosines is going to come up later. It's actually going to be a little easier. But here we go. Let's start with the law. The law of sines. Now, this works for any triangle that exists. It does not need to be a right triangle. In fact, I made this a clearly obtuse triangle just to prove the point. It works for any triangle. Just because we're using the sine and the sine is associated with a right triangle doesn't mean that it won't work. It'll work for any triangle that exists in a 2-dimensional plane. And there's this certain poetic simplicity to it too. If you take any side divided by the sine of its opposite angle, it'll be equal to the ratio of another side divided by the sine of its opposite angle. And let's take a second to look at this triangle here. The triangle has capital A, B, and C. These are points. And lowercase a, b, and c. These are the length of sides. So you'll see that capital A, this angle and point right there, this vertex of the triangle, is opposite the lowercase a, which is the length of the side there. So I wanted to point that out because it's a little weird, but you can get used to it. The capital letter signifies the angle or this vertex, and its opposite side. We join these 2 things together. So we're saying that the length of this divided by the sine of this angle is equal to the length of this divided by the sine of this angle. But that's also equal to the length of this divided by the sine of this angle. And if you prefer, I've seen the law of sines with the angles on top. You could do that as well, just taking each of these to the -1 power. But I'm going to be keeping with this version of the law of sines. So let's look at a triangle. Let's look at this triangle. Now, this is a typical triangle where we have 2 angles and a side given. Eventually, you'll be at the point where you can get any 3 parts of a triangle and find the other 3 parts. But we're going to start with the law of sines, referring to when you're given 2 angles and a side. And the side does not need to be included. This one is. This works for both when the side is not included inside the angles and when the side is included in there. It works the same way. We can find the length of the third angle pretty easily because any 2-dimensional triangle has 180 degrees as the sum of the 3 angles. You can find angle C pretty easily. But finding the length of the sides requires your knowledge of the law of sines, which, let me refresh your memory, is right up there. So you'll see that I found that the measure of angle C ended up being 64. And then because I like equations with 2 sides, I decided to just group the A and the C together. I was like, okay, well, I want to find, I know the measure of this angle, and I know this is 13. So I want that to kind of be the basis of this problem. If I find that the measure of angle C is 64, and this is 13, I loaded this into the law of sines. I put Y as my side opposite A there. And then it's just a matter of cross multiplication. You can get the exact answer, but probably you'd want to find out the approximate answer, which turns out to be about 1075. That buzzer means that I'm right.